Hey guys, get your candy, $2. Come to my classroom and get it. Okay, today we're going to talk about bisectors of triangles. So I need you to write these definitions down in your notes. The first one is a bisector. It cuts things in half. So if I have a line right here and I tell you that that's a bisector and I tell you that this is 6, then that means that this is 6 too. It cuts things, bisects, okay? Cuts something in half. Bi means 2, so when you cut something into 2 pieces, it bisects. Perpendicular bisector means that it cuts a segment in half and forms a 90-degree angle. So if this was a perpendicular bisector, then not only would it cut this segment in half, but it would form a 90-degree angle. So the first theorem that you're going to learn about this is this, and you need to write this down in your notes. If a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So write that down, but what does it mean? So here is a segment, and we see that it's 5 and 5, so that means this is the midpoint of that segment, or this line bisects it. I also notice that this line forms a 90-degree angle. That means that any point on this line is going to be the same distance from the endpoints as each other. So when I draw 2 triangles like this, I can say that these 2 pieces are equal just because of this. If a point is on the perpendicular bisector of a segment, then it is equidistant, and that means equal, from the endpoints of that segment. So basically, those 2 segments are equal. The other theorem that you're going to write is if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector. So if I show you something like this, and I don't tell you that that's a 90-degree angle, but I tell you that this point is equidistant from the endpoints of a segment. So if I tell you that these 2 are equal and there is a point on this segment right here, then I can say that this is the perpendicular bisector. So that would be, those would be equal to each other. Okay, so let's look at some examples. This section is broken up into different sections, so we're going to just look at some examples right now. Find AB. Okay, well, AC is 4.1. These 2 are equal, which means this is a bisector right here. And it also tells me that it's 90 degrees. So if this line is a bisector, and it's telling me it's 90 degrees, then I know that this point is equidistant from those 2 points. Therefore, AB is 4.1. Okay, here it says find WY. Okay, well, I know that these two lines right here are both 9. And I know that this point right here is on a perpendicular line. So if that's on a perpendicular line, and I know that that's 3, then I can say that WY is 3 because of those theorems. Okay, over here, example 3. This tells me that this is a bisector because it's right here, and that is a perpendicular line. So what can you say about these 2? This is equidistant from both of those points, which means these are both equal. So how do I solve for x? 2x plus 3 equals 4x minus 7, and I have to go ahead and solve for x. So if I subtract 3 from both sides, I get 2x equals 4x minus 10. And then I'm going to subtract 4x from both sides, and I get negative 2x equals negative 10. Divide both by negative 2 to get x alone. X equals 5. So that would be my answer for that one. Over here, it says find each measure. So in this one, I know that these 2 are equal, so that's a bisector, and I know that forms a 90-degree angle. That means right here is going to be equidistant from both of those points. Therefore, I'm looking for BC, and BC is 8.5. Down here it says find XY. Well, it tells me that this is perpendicular, and so this point is going to be, this line is going to be the perpendicular bisector. It's perpendicular, and so I have to find XY. So that's going to be 6. There is a theorem that you haven't learned that tells us about triangles, And the theorem says that, see, this side of the triangle is the same in both of these triangles. The theorem says that if you have a 90-degree right triangle and you have one leg that's equal to each other, so in this triangle and in this triangle, we have two 90-degree angles and we have one leg that's equal to each other, then the whole triangles are congruent, and therefore we can say these two pieces are congruent, and therefore that's the perpendicular bisector. The same thing goes for this one. This is called the HL theorem. Actually, that's not the HL theorem. Okay, hold on a second. In this one, 3x plus 1 and 5x minus 3, this is a perpendicular line. So 3x plus 1 equals 5x minus 3. So we can subtract 3x from both sides and get 2x, and then add 3 to both sides equals 4, so x equals 2. There's some things in geometry that we haven't gone over yet that would make these things a little easier for you, but we'll have to come back to those other things. So anyways, we'll see you tomorrow.